Notes on lesson 6.1. This lesson is all about slope, and the slope is just a measure of how steep a line is. The higher, the more steep a line is, the higher the slope is going to be. The less steep a line is, the lower that rate of change or the slope is going to be. We've talked about this prior to this lesson. It came out of that red book where we've defined slope. And slope is usually all of these different types of words. It's the rate of change, it's the rise over the run, it's the vertical change over the horizontal change, it's the change in the dependent variable all over the change of the independent variable. So anytime we talk about slope, these are also interchangeable words. In that slope, you're going to be looking for the rate of change in, say, a table. And they want you to actually use day 5 and day 2. So we're going to look at day 5, that is $120, and day 2 is $75. So we want to find the change in our y values, which is that second table. So we're going to look at 120 minus 75. Then we're going to look at the change in the x values. So day 5 and day 2. Again, you want to keep them from the same spot. So 120 minus 75 is equal to 45. And 5 minus 2 is equal to 3. So that change would be $15 per day. And that's what that rate of change is going to talk about in this situation. We do want to put in the real world meaning into each of these things. Now, in graphing, the rate of change can also be seen, and we want to look at it as terms of how far something goes up versus how far something goes over, or that rise over the run. So to find that rate of change, you can choose any points along this graph. You want to find points that are on kind of the corner of these boxes. You could start also here at that origin, which is 0, 0. And again, you can go to any of these dots along this line. Each of these dots would make sense. You have to keep in mind that rise and how far that run is. The rise here in this situation has a different scale. It's actually going up by 50s. So each one of these boxes is worth 50. So if I went up 3 of these boxes, that would give me a rise of 150 miles. Now I would have to divide that by that run, and that run here would be 3 units, and so it would be divisible by 3. So the rise over the run. In this case, 150 divided by 3 gives me a slope of 50. And when I want to put that in terms of the situation, the rise is dealing with miles. The run is dealing with hours. So this becomes 50 miles per hour. Now with each of these slopes, again, just like we had done before, you want to find something that puts you on the corner of a box here so that you have whole numbers. You don't want parts of numbers in between here. Those would not be good points to find the slope from. Again, you're going to put in your slope triangle. Rise over the run. And so in this case, this one is a positive slope. It goes up and to the right. So we're looking from one point to the next. How do you get from one point to the next? You'd have to go up 2 units and to the right 5 units. So the slope of that line is 2/5. Now in letter B, this has a negative slope. We always read slope from left to right. So that means that we're going to pick 2 points. We're going to look at these 2 points. And on the graph, you would go down and to the right. Now you can also see in the work below that you can use the points. You can use the y values first, 2 minus that 5 on the top, so the change in the y values, divided by the change in the x values, 4 minus negative 1. And that's what they did here. And that is how they came up with a negative 3/5. Now, finding the slope of each of these lines, we're going to use the rise over the run. So we're going to go from these points up and how far over. So we went up 1, 2, 3 units here, and a run of 1, 2, 3, 4, 5 units. This is a positive slope as it goes up from left to right. So this slope would be 3/5. Now letter B, this has a negative slope as it goes down from left to right. And when I put in my slope triangle, again, you do have to get all the way over to that dot. So as I look at that, I went down 1 unit, so -1, divided by 1, 2, 3, 4, 5, 6 spaces. So that slope is -1/6. Now, this is our slope formula. And in the slope formula, you're going to see that, again, it's y2 minus y1 divided by x2 minus x1. Now, this can also be rewritten as y1 minus y2 all over x1 minus x2. It doesn't matter which one you actually choose. You can go back and forth, but you do have to make sure that that number comes from that same point. So if it's either the first point, that is your first number, or the second point, that's your first number. But you can't interchange them. And that's kind of what these arrows are showing you. So if I do 7 minus 1, I have to do 6 minus -2. I can't put the arrows in opposite directions. You can also see in the slope triangle, you really are finding that change in y and dividing it by that change in x. So using that, find the slope of these 2 points. So again, we're going to look at the change in y values, so 7 minus 5 divided by the change in x values, 4 minus 2. The rise or the y's have to go on top and the run goes underneath. 7 minus 5 is 2, and 4 minus 2 is also 2. So the slope in this case would actually be 1. Do the same thing with letter B. We're going to change the y's, so -2 minus 4, then subtract the x's, 3 minus -1. -2 minus 4 gives you -6. And when I have a negative minus a negative, it becomes a plus, or SMATO, which means that subtraction means add the opposite. So it becomes 3 plus 1, which is 4. Now looking at that, I can see that I need to reduce that. So I'm going to make it -3/2. Now there are 2 special cases that we look at the slope. We have what's called a horizontal line. And that horizontal line, as I look at that line, I kind of think, well, if I were a skier and I got on a horizontal line, that line would actually be 0 fun. I wouldn't go anywhere. The other thing to look at that, you pick some points. This has a 0 rise and a run of 4 units. So the slope of a horizontal line is 0. A vertical line looks like this. It's the up and down, like if you were going to measure your vertical. It's how high you can jump. A vertical line, however, has kind of a situation. If you were a skier and you got on this vertical line, you would actually fall to some undefined human form. So we don't really know what that human form would look like, but here's the idea behind that, is that you have a specific rise but you end up dividing by 0. And when you divide by 0, we actually say that that is undefined. So in math, we talk about anything that's divided by 0 as undefined. So a vertical line has an undefined slope. A horizontal line has a slope of 0. So as you look at this kind of sets you up. It summarizes everything that we've gone over in this lesson. A line with a positive slope is going to slant upward from left to right. A line with a negative slope slants downward from left to right. A horizontal line looks like this, side to side, 0 fun, has a slope of 0. And these equations are going to look like y equals 2 or y equals 5, y equals some number. A line with a vertical slope, which is undefined, and that is going to look in the form of x equals a number. So very different than what we've seen in the past.